Good day, class. It's Sir Capistrana again, and welcome back to another discussion here in Math 1 Statistics, wherein for today, we'll be actually looking into another topic, and that topic is what we call ANOVA. And by ANOVA, it is the analysis of variance. So this will be the last topic for our statistics. So hindi ko na susundin yung ating syllabus wherein included pa yung chi-square. So, we will be allotting the remaining days of our course, of our semester, for your review. So, for today, we will be looking into the last topic here in statistics. And that is ANOVA, or Analysis of Variance. So, by Analysis of Variance, this actually allows a researcher to compare two or more population of interval and ratio data. This is actually not so different. By not so different, it still tests the differences between populations. But for this one, in comparison with the other test statistics that we already discussed, analysis of variance actually allows researcher to compare two or more population of interval and ratio data. So it is extremely powerful in commonly used in statistical procedure, especially in experiments having multiple treatments. As you may have remembered last time, I mentioned regarding experimental studies, wherein you can actually set a control setup and an experimental setup. But in some cases, there are actually a lot of other treatments uh, for a certain experiment. So, limbawa, meron kang isang control study, meron kang treatment 1, tapos meron kang treatment 2, treatment 3, and so on and so forth. So, we cannot actually use our usual t-test or say-test for those type of experiments because there is actually that limitation in the t-test and the say-test wherein we can just compare two samples. But for analysis of variance, there is actually a way to test kung yung lahat ba ng setups na yon, more than two setups, ay meron ka bang makukuhang differences. So, that's why it is extremely powerful and commonly used as a statistical procedure. So it actually determines the difference between the population means wherein it actually uses variances. Kaya sinatawag natin siyang analysis of variance. Ang ibig kong sabihin dun sa analysis of variance na yun, it actually uses the variance of each of the setup or each of the observation set para i-test mo kung may difference ba yung population means. So, kumbaga, yung variance we will be using the variance to test for using the variance to test for the population means. Kaya sinatawag natin siyang analysis of variance. So, in analysis of variance, yun lang, kailangan lang natin dito, syempre, we need population 1, 2, and 3. We will be needing their means. We will be needing their variances. And in that, yun yung medyo hindi nakakatawa dito sa analysis of variance since marami nga yung samples mo, medyo maraming computation yung kailangan natin gawin. But in any case, I will guide you through it and hopefully I will do a great job on instructing you on how to do this. So, in that, we have here this three types of ANOVA. So we have the one-way analysis of variance, we have the randomized block design, we also have a two-way analysis of variance. But for the specific discussion and for our course, we will be only using the one-way analysis of variance. Okay, so that is what's included in this video. So in that, let's proceed to the procedures. Right? So, by procedures, we will first need to look into the assumptions of analysis of variance. And as I said, one-way ANOVA is actually an analysis of variance that compare the population means of different groups. By groups, it can be two or more groups. It is used to accept or reject null hypothesis that the population means of each group does not significantly differ. So, yun lagi yung ating null hypothesis dito. We are to say that the means of each group does not significantly differ. So just like our t-test and say-test, ganun lang din yung concept na kailangan nating matackle. We need to look into those difference of the means. Okay? And hindi porket meron silang kaunting difference ay significant na yung difference. So, we will be using one-way ANOVA to check for that significant difference. Okay, so for the assumptions of one-way ANOVA, the samples are randomly selected just like t-test and say-test and independently assigned to each group. Okay? And the populations have approximately equal standard deviation, and also population distributions are normal. So just like our t-test and say-test. Okay? And in that, we have this procedure. Papansinin natin parehas lang naman pala, di ba? Kailangan lang natin mag-set up ng hypothesis, kailangan natin i-set yung ating level of significance. Ang kaibahan lang for one-way ANOVA, syempre, we will be using the F-test instead of t-test and say-test. So we will be getting the means of each group, we will be getting the grand mean, the sum of squares, and the mean of squares, the value of F-test. So, kaya siya medyo tedious dahil dyan sa dami ng mga compute natin yan. Pero, it will make sense later on once we actually look into the computation itself. So, for the statistical decision, ganun pa rin If your F computed is less than your F critical, do not reject the null hypothesis. And if the F computed is actually greater than or equal to our F critical, we need to reject the HO. Okay? So, ang medyo limitations lang ng ating one-way ANOVA, hindi tayo pwedeng mag-check ng greater than or less than since we are to compare multiple groups, more than 3. So, ang hirap namang mag-set ng one-way test doon. So, pero more regarding that, yung ANOVA natin, ang tinetest niya lang actually isang curve lang. One way yung itsura niya, but in any case, wala tayong distinction kung one way or two way or two-tailed one-tailed or two-tailed yung ating mga gagawin. So, in any case, para lang magkaroon tayo ng guide kung ano yung mga kukompute natin kasi from our discussions, okay na yung hypothesis madali na yung pag-set up ng level of significance kasi for one-way ANOVA, we are only using 0.01 or 0.05. So, choice lang yun, dalawa lang yun. And for, ito lang yung medyo magtatagal tayo, step 3 at saka yung step 4. But for the step 5 and step 6, hindi na to bago sa atin. And to guide us regarding those computations na kailangan natin gawin, meron tayong table na ginagawa for one-way ANOVA wherein we will be filling this up. So, ito yung sinasabi natin kanina, the sum of squares, yung grand mean, nandito silang lahat yun. So, for the SSB, or yung tinatawag nating sum squares between groups, kaya siya B, kasi between groups, these are the treatments, kung ilan sila. All we need to do here is just get we just need to get the mean of each group. Ito yung X bar J minus yung ating X bar GM or yung tinatawag natin na grand mean. We just need to square that. We can get our sum of squares between groups. Yan yung total, kumbaga, all in all. And within groups, ito naman yung bawat isa na titingnan natin dito yung bawat sample naman. Kaya kung makakita nyo dyan, XJ, ibig sabihin yan yung mean sa bawat group. And XIJ naman, yan naman yung mga observations per group. So, we also have these degrees of freedom. So, for between groups, C here will be the number of groups or treatments na ginamit natin. So, kumbaga kung meron kang apat na group, your C will be 4. And for N naman, or dito sa degrees of freedom within group, ito naman ay yung number yung total natin, total nung lahat ng observations natin minus yung kung ilang groups meron tayo. So N here will actually be all of the observations. Okay? So ganun lang din, using this sum of squares and degrees of freedom, we can actually compute for the mean square. So for the mean square, ang kailangan na natin dyan gawin, yung ating SSB, we just need to divide that by the degrees of freedoms between groups para makuha yung MSB or the mean square between groups. Kaya siya MSB. Then for MSW or mean square within groups, all we need to do there is divide the sum of squares within group by the degrees of freedom within groups. Then, saka na natin mako-compute yung ating F value. So, ito yung ating F computed. Okay? So, mahaba-habang proseso yung sa pag-compute natin ng F computed kasi kung isipin din naman natin kung halimbawa ang gagawin nyo ay instead of ANOVA, gagamit kayo ng t-test kung magiging valid ba yun. Halimbawa, meron kang apat na groups. Sabihin natin, ito yung first group, ito yung control mo, second group, third group, and fourth group. So, ito yung treatment 1, treatment 2, treatment 3. Ang gusto mo na-check kung ano ba, kung may significant difference ba yung control, yung T1, yung T2, at yung T3. So, nag-decide ka, sabi mo magti-test ka. So, mangyayari, pag nag-test ka, compare mo to, then compare mo ulit yung control dun sa T3. So, tedious din siya. So, kumbaga, actually, ang ANOVA, pwede mo na siyang i-consider na shortcut in any case. And also, there are actually some applications that you can use to compute for ANOVA, pero hindi ko muna yung babanggitin ngayon kasi ituro ko muna sa inyo kung paano yung manual. In any case, those are the required values for the computation of our F computed. And so para naman dun sa ating grand mean, kasi wala dun yung formula ng grand mean natin, all we need to do for the grand mean is just get all of the values and divide the values by the sum of the n of each or the sample size of each group. So, halimbawa, meron kang group A, group B, and group C. So, sa group A, group B, group C, meron kang ganitong values. Meron 1, 2, 3, tapos meron ka rito 5, 4, tapos meron ka rito 2, 3, 4. So, ganyan yung itsura ng ating sample size. So, for the grand mean, all we need to do is we just need to get the sum of all of this. And kung makikita natin dito, ang n natin dito sa baba, for NA, okay. So, for NA, ang NA natin ay 3. Tama ba? Ang NB natin ay 2. Then, ang NC natin will be equal to 3. So, para dun sa N natin na to, dito sa N na to, all we need to do is just get the sum of this. So, we'll have here, ang total N natin, that will be 3 plus 2 plus 3. So, that will be 8. Okay, so, yan na yung N. So, how about nung summation dito sa taas? Ang kailangan lang natin dyan gawin is i-add lang natin lahat ng values na to. So, ang pinakamadali dyan gawin, compute mo muna yung total ng A. So, 1 plus 2 plus 3 is just 6. 5 plus 4 is just 9. 2 plus 3, that's will be 5. Plus 4, that will be 9. So, kung gagawin mo na lang, para din sa part na to, all you need to do is to add all of this. So, you'll have 6 plus 9 plus 9, that will be 24. So, for our grand mean, that will be equal to 24 divided by this n, which is 9. So, yun na yung magiging grand mean natin. Right? So, nagmukha lang siyang nakakatakot gawa ng mga summations natin. But ang ibig lang sabihin niyan kasi, pag sinabi niyang xij, uh, yung ij mo kasi, that will be your row and column. So, this will be our, itong 1, that will be our x1, comma 1, sorry. Then, itong 2, that will be our x1, comma 2. Kaya siya naging xij. So, that will be, itong 3, that will be x1, 3. Itong 5, that will be x2, kasi second column na siya, 1. This will be x2, 2. So, i-add mo lang yung mga yan. Yun yung ibig sabihin niya. So, hindi mo kailangan matakot dyan sa values na yan kasi ang ibig lang natin sabihin dyan sa grand mean, we just need to add all of the values. Okay? So, as for our F critical, ito yung nasa may step 5 naman, step 4, wherein we need to compute for our F critical. So, para din sa F critical, ang mga kailangan nating tingnan dito ay we need to take the critical values from what we call F distribution. There are actually two types of F distribution. We have the 0.05 F distribution and the 0.01 distribution. And to give you an idea kung ano yung itsura nila, I actually get here this F distribution for alpha which is equal to 0.05. Iba pa yung sa 0.01. So, kumbaga, paano gamitin ito? All we need to do is we just need to get the number of groups and kung ano yung observations dun sa bawat group. So, for example, I have here, we have two groups. So, ang mangyayari, that will be C is equal to 2. And for each group, we have 11 observations, 2 groups times 12, that will be 22. Okay? So, paano natin gagamitin yung values na yan? So, itong nasa taas, that will be actually the value of your C's. And dito sa pababang yan, that will be the value of N. So, for 0.05 alpha or level of significance, we have 2. Ito yun, 2. Then we should just need to look for 22. So, ito yung magiging value natin. So, for this one, our F critical will actually be equal to 3.443. So, yan ang pagkuha naman ng ating F critical. Okay? So, what's the next step? The next step is actually to have an example. Okay? So, we have here an example wherein the problem states that a VSF student was interested in determining whether any difference existed in the average taste test result of 4 fish food products. So, bakit ko ito ginawang example? Actually, dito sa course nyo, sa BS Fisheries, there are actually a subject called fish processing wherein you will be creating different products tapos magpupunta kayo ng taste test. Kaya meron ako ditong 4 na products, apat na fish food products and a random sample of 5 taste tests for each food product was taken. So those are the scores. So at the 0.5 level of significance, is there an evidence of significant difference in the taste of the fish food product? So ganito yan yung pwede nating gawin or gamitan ng tinatawag nating ANOVA. So kung iisipin nyo dito, kung hindi dito pwede ang t-test, hindi rin pwede rito ang say-test. Kasi meron tayong 4 na groups. Kaya, ano ba yung gagamitin natin? So, for step 1, all we need to do is state the hypothesis. Okay? So, pwede nyong i-state na ganito yung itsura nyo. Itsura ng ating hypothesis. Pero kung nasanay na kayo rin sa ginagamit natin dati, pwede ang null hypothesis natin, isusulat nyo dyan, imbes na all products have equal taste test result, pwede mong sabihin dyan na there is no evidence or significant there is no evidence to conclude that there is a significant difference between the taste test result. And for null hypothesis or alternative hypothesis, pwedeng imbes na not all food products have equal taste test result, you can actually rewrite that as there is a significant difference. There is a significant difference between the taste test result of all food products. So, pwedeng ganon. Okay? Or pwedeng sabihin, there is enough evidence to conclude that there is a difference between the taste test result of all food products. Imbis na ganitong way ng pagkakasulat ng hypothesis at saka alternative hypothesis. But this is just the simplification of our hypothesis. So for step 2, all we need to do is determine the level of significance binigay na yun sa ating kanina sa problem, wherein our alpha there is 0.05 or 5%. Alright? So for step 3, we just need to calculate for the means of each group, grand mean, sum of squares, and mean of squares. And for this video, para hindi maging matagal yung transition natin sa mga bagay-bagay, I actually included the computations for the means, the grand mean, sum of squares, and mean of squares. So, i-guide ko na lang kayo kung paano siya titingnan. So, ang best way na pagsimula dito or pag-compute dito is compute nyo na muna yung totals. Yan ang tutulong sa inyo sa pag-compute ng ating mean of each group, grand mean, sum of squares, and mean of squares. More on dun lang sa means of each group and grand mean, pero it will be helpful to first get the total of each group. Kasi mula dito, pwede mo lang compute yung mean of each group. Halimbawa, for the mean of A, kailangan mo na lang gawin dyan, since 5 yan, kunin mo na yung 65, you have 65 divided by 5. So, meron ka na ng mean of A. So, this is actually 13. So, ganun din dito sa XB or sa mean ng ating food B. So, you have 63 divided by 5. So, that will be 12.6. Okay? So, ganun din dito sa ating food C. Pwedeng mangyari dyan, we will have 69. Lagyan muna natin yung x bar of C. That will be 69 divided by 5. So, that will be 13.8. Okay? Then, for dito naman sa dulo, so you will have mean of D will be equal to 60 divided by 5. So, mas madali mo na siya compute. Ganon din sa grand mean. Kasi ang pwede mong gawin na lang dyan, all you need to do is get the sum of lahat ng ito. So, you'll have 65 plus 63 plus 69 plus 60. Then, you just need to divide that by 20. Bakit 20? Kasi, as you may see here, meron tayong 4 na groups, tapos meron tayong 5 sample per groups. So, you'll have 5 times 20, 5 times 4 is equal to 20. So, you'll have an N, which is equal to 20. Tapos, pag in-add na lang natin yan, we'll have 65 plus 63 plus 69 plus 60. Okay, so that will be 17 tapos 25. So you'll have 257 divided by 20. Makukuha mo na yung grand mean mo. Kasi your grand mean will just be equal to 257 divided by 20. Okay? So pakita natin yon dito. So yan yung mga means natin. Makikita niya. So, we'll have there yung mean ng A, mean ng B, mean ng C, at saka ng mean of D. We'll be using this later on for the means between groups. And for the grand mean, yung sinabi ko nga kanina, you just need to get the summation of A, summation of B, summation of XC, and summation of XD. Then, divide that by the sample size of N, plus the sample size of B, plus the sample size of C, plus the sample size of D. So, ganito na nga yung naging itsura nun. So, we'll have 257 divided by 20. So, you'll have there 12.85. So, that will be your grand mean. So, saan na natin gagamitin yung grand mean at saka yung mga means between groups natin? So, ang pinakamadali doon ay gumamit mamaya ng table. But in any case, for our SSB, or the sum of squares between groups, all we need to do now is get the difference between our XA minus grand mean tapos XB minus grand mean tapos XC minus grand mean tapos XD minus grand mean. Then you just need to multiply that by what you call this, your N, or the total of N. Yun yung tinatawag nating NJ. So, paano gagawin yun? So, ganito siya. So, we will have here, ganun yung gagawin natin. So, we'll have isa-isahin natin for XA. We'll have 13 minus 8, not 8, 13 minus 12.85. So, that will be equal to 0.15. For the X, minus grand mean ito ha. Grand mean. Okay, so XB minus grand mean, that will be equal to our 12.6 minus our 12.85. So we will have here negative 0.25 o 0.15 ba yan? Okay, check nga. So we'll have there 25. So then for our x bar C minus our x bar grand mean, that will be equal to our 13.8 minus 12.85. Okay? So, compute na natin para hindi ako nagtatagal. Okay, so that will be 13.8 minus 12.85, so that will be 0.95. Then we'll have yung sa last one, yung sa XD, that will be 12 minus 12.85, which is equal to negative 0.85. You just need to add all of this. So you'll have 0.15 minus 0.25, tapos meron tayo minus 0.85. So that will be equal to, we need to square them first, then pagka-square natin, saka natin i-add, then saka natin i-multiply din sa 20. So, kumbaga, square mo muna itong 0.15. So, that is 0.0225. Then, you'll have here 0.465 ba? Tapos yan. And so on and so forth para makuha yung ating 8.55. So, pakita lang natin. So, we'll have there 0.15 square. That will be equal to 0.0225. Then we'll have there our negative 0.25, and you just need to square that. So you'll have 0.0625. Then you'll have 0.95. And you just need to square that, so that will be equal to 0.9025. Then we'll have here 0.85, and you just need to square that, so that will be 0.7225. Then you just need to add all of them, so I'm adding already. So I have here, parang mali. Ilang glass. nangyayari sa akin. So, ang next natin dyan, we need to multiply them by xn. So, you just need to multiply them 5. So, para makuha yan, pagka-multiply nyo, makukuha nyo na itong 8.55. Okay? So, ano nga ulit yung ginawa? All we need to do is get the difference muna para dun sa SSB. So, you'll have 13 minus 12.85. Tapos, pagkakuha nun, you just need to square that difference. So, kumbaga itong 0.15, ginawa natin 0.0225 kasi naging square siya. Tapos, multiply natin by 5. So, ganun din gagawin natin para dun sa B, sa C, at saka sa D. Tapos, saka natin siya i-add lahat. Okay? So, that will be how, the process on how you can compute for the sum of squares between means. So, para naman dun sa sum of squares within groups, ito naman yung gagawin nating process. You need to account for your XA or X bar B, your X bar C, and X bar D. Then, gagamitin nyo siya para kunin yung difference ng mga yan dun sa ating mga data dito sa una. So, kumbaga, kaya nakuha tong 1, kasi ang ginawa natin dyan, yung 12, minus natin yung 3, yung 13, so nagkaroon ka ng negative 1 dyan, tapos in-square mo, kaya siya naging 1. So, para naman dito sa 0, bakit siya naging 0? That will be 13 minus 13, kaya siya naging 0 kasi ang 0 square ay 0. So, we'll have here 14 minus 13, that will be 1. 1 square is 1. Kaya naman to 4 kasi you'll have 11 minus 13, that will be negative 2. Then you square that, kaya tayo nagkaroon ng 4. Kaya sinasawag natin siyang sum of squares within group. Then, all we need to do now is to compute ulit yung sa 15 minus 13, that will be 2 squared, kaya siya naging 4. Similar concept yung dito sa ating 2.56. Kasi bali nangyari dyan, you'll have 11 minus your 12.6, kaya siya naging 256. Kasi magkakaroon ka dyan ng negative 1.6 and negative 1.6 times negative 1.6, that will be equal to 2.56. So, ganyan din yung sa mga sumunod, paano siya ginawa. Okay? So, hopefully, hindi tayo nalilito na. So, supposedly, ang ma-minus nyo dito sa mga data ng food B ay yung mean ng food B. Tapos, i-square nyo siya. Then, para naman dun sa C, itong C na to, itong C's natin, i-minus lang natin yung 13.8 kasi yun yung mean ng C para makuha natin yung itong mga to. Pagka-square natin. Okay? So, ang gagawin natin dyan, all we need to do there is just to get the sums ng ating mga data. So, ang sum na sinasabi ko, that will be 1 plus 0 plus 4 plus 4 plus 4, that will be 10. Same for 2.56 plus 6.76 plus 0.16 and the like. Kaya nakuha yung 17, yung 18, at saka yung 14. So, gagawin lang natin ngayon is we just need to get the sum of all of this para makuha natin yung tinatawag nating SSW. So, ito yung nangyari doon. Kaya tayo nagkakaroon dyan ng 10 plus 17.2 plus 18.80 plus 14. So, saan yan galing? Galing yan dito. So, ginawa natin ganyan. Okay? So, that is the sum of squares within groups. So, meron na tayong SSW which is equal to 60. And from this point on, ito na yung medyo madaling part ng ating pag-compute ng ANOVA. So, as long as naging maayos yung pagkuha mo ng SSB, na kinuha mo muna yung grand mean at mean ng bawat group, tapos kinuha mo yung difference nila, tapos in-square mo, tapos minultiply mo dun sa kung ilan yung population per group, makakompute mo na to. Then also, for the SSW, you need to follow this table wherein kailangan mong kunin yung squares ng difference ng x mo sa bawat group minus yung ng mean ng bawat group na yun. And in that, makukuha mo yung sum of squares within group. And using that, meron na tayong dalawang values. Meron na tayong SSW and SSB. So, makukuha na natin yung ating sum square total, which is actually, you're just getting the sum. So, ito yung ating SSB kanina, yung 8.55 at saka yung 6. Yung SSW naman natin ay yung 60, kaya ang SST natin ay yung 68. So, makapansin nyo rin sa table na binigay ko kanina, we actually filled up the second column nung nung ginawa natin kanina. So, ang next naman natin kailangan gawin is to compute for the MSB and the MSW, or the mean squares between group and the mean squares within group. So, ang gagawin lang natin dito, we just need to get the SSB. Then, all we need to do is get the number of groups, yung C. Okay? Minus 1. Kaya tayo nagkaroon dyan ng 8.55 divided by 3. Kaya nakuha natin yung 2.85. Similar naman halos dito sa MSW. You just need to get your SSW kanina, which is equal to 60. Then, we have an N that is yung lahat-lahatan, which is equal to 20. Tapos, meron tayong groups na 4. Kaya nakuha natin itong 60 over 20 minus 4, which is equal to this. 60 over 16, kaya meron tayong 3.75. Okay? And using that, pwede na natin ma-compute yung ating F computed. Wherein ang F computed natin will be our MSW, or the mean squares between group, divided by the mean squares within group. So we'll have 2.85 over 3.75, and we will have there 0.76. And in that, to compute for the degrees of freedom and the critical value, ganyan lang ulit, degrees of freedoms between group muna tayo, so that will be the total number of groups, which is 4 minus 1. Kaya nakuha natin yung 3. Okay? Then we will have the degrees of freedom within group, so that will be your N, which is 20, minus C, which is 4, kaya naging 16. Kaya kung makikita yung, ay, nabilugan ko na dati. So that will be 3, 16. So, tapat-tapat lang, kaya meron tayong 3.239. So, the F critical will be F3, 16. And pwede nyo i-round up, wala namang problema. Okay? So, meron na tayong F critical, meron na tayong ANOVA table. So, ito yung nakuha nating SSB kanina. Ito yung ating SSW. Ito yung degrees of freedom within, not within, that is between groups. This is the degrees of freedom within groups. This is the MSB, or the mean square between group. This is the mean square within groups. Tapos, ito naman, that will be our F computed, which is actually equal to our MSB divided by our MSW, which is equal to 0.76. Okay? And yung total lang, kinuha lang natin yung total ng ating degrees of freedom, kaya nakuha natin itong 19. In any case, since ang F computed natin ay equal to 0.76, tapos ang F critical natin ay equal to 3.49, nga ba yun nandun? Anong magiging decision rule natin? So, tingnan natin dito sa next slide. Since, hindi pala 49, that should be 24. Check natin saglit. Baka may malito mamaya pag may bumalik din sa video. So, that will be 3.24. So, 3.24. So, in the end, our decision rule ay titingnan mo yung F critical at saka yung F computed, and since yung F computed natin is less than dun sa F critical, it is safe to assume that the F computed value is less than F critical value, which is 3.24 at level of significance of 0.05. The statistical decision is not to reject the null hypothesis. Not to reject, ang ibig sabihin, we have here this conclusion that since null hypothesis has not been rejected, we can conclude that there is no evidence that shows significance difference in the means of sales of food products. So, pwede nyo mapansin dito na mali yung nakalagay. That should be the taste test result. Bang iniisip ko. Result of food products. So, yan yung magiging conclusion natin. Kaya sabi ko sa inyo, pwede nating i-reward yung ating hypothesis kanina in a way na magiging align siya rito sa hypothesis natin na to. So, pwede nating sabihin to na yung kanina, yung sa null hypothesis natin, pwede nating iset na ganyan. There is no evidence that shows that significance difference in the mean of taste test results of food products. Okay? So that is how we conclude our ANOVA, or one-way ANOVA. And in that note, I will be leaving you this exercise or this assignment. So for this assignment, you just need to get to conclude that there is a difference in the mean number of hours spent by students for their studies. So in here, we have the registrar of a state university wishes to study the number of hours students spend for their studies. And the registrar has a sample of 7 BSF students, 6 BSHRM students, and 5 BSEd students. At significance level of 0.01, and he concluded that there is a significant difference between the mean number of hours spent by students for their studies. I will be releasing the answer for this assignment on after the deadline of our assignment. So I will be creating another submission bean for this assignment. So if you don't have any question, and if you have any question, pwede kayong mag-comment or pwede rin kayong mag-chat na lang sa akin through our selected channels. So, with that, that ends our discussion regarding analysis of variance, and that also ends the discussion for our Math 1 statistics. So, in that, good luck on your exams and have a great day. Bye!